high-speed milling machines, minimum coolant, vacuum work holding, or single fluid end mills. All of these keywords are mostly used when it comes to milling with DATRON CNC machines. But what does it mean? What is the difference between a DATRON CNC system and a traditional milling center, like a vertical machining center? We take a close look at the entire chain that you see daily in your job shop, in your company, from the machine, from over the tool, to all the processes, to the accessories of a machine. What does DATRON stands for? So we're gonna have a quick overview of like typical applications, and then we go through all of these big bullets. Welcome to the DATRON BIG5. I've prepared a bunch of typical applications here on my workbench. So what you can see on the first look is most of them are aluminum, and that's basically our strength. So aluminum material, non-ferrous materials like copper, brass, etc., and plastics, reinforced fiber, or even foam cutting. All of these applications should be considered in relation to a DATRON machine. So let's take a look at these different parts. We got a structural elements made out of an aluminum plate, perfect for vacuum holding. We got a shoe mold, like a sole mold here as a prototype. Structural element for aircraft interior. So that's a very like a 70 series aluminum, so kind of a harder aluminum. HF antenna, a lot of tiny little pockets and details, a lot of tiny features. So that's where we take benefit from the high RPM. Typical cover of an electronic cabinet with a lot of engraving on top for different like knobs and switches. And this part is a structural element for a SCARA robot, so it's basically like for horizontal movement. That's kind of a bigger part for our machines. It kind of sets more or less the limit of in thickness what the machines can handle. Because of the high RPM, the tools and spindles are very sensitive for vibrations, so the longer the tool gets, the more critical it will be to get a good quality on the part and not to harm the spindle in any ways. Reinforced fiber, that's like carbon fiber, a structural element. And as I said, for foam cutting, like a shadow board for different tools, for toolboxes. That's all of these examples are where tool technology comes into the game. So we would not use just single fluid cutters on carbon fiber. There is our expertise in different tools and different tool strategies. And also when it comes to accessories, this part is made on the 4th axis, on a rotation axis. It's an endoscopy camera, prototype housing, so that's how you grip it. So we got multiple indexing or orientations on the part. So some holes come from the top, some from this angle, so a lot of movement in this direction. So everything of this is possible on machines, and in the first step, the machine, that's where we take a look at the different sizes of the machine. What are the big bullets of the machines? What are the significant differences to a conventional machining center?